All right, welcome back. So, got a problem here that poses a bit of a challenge because what I have always said is that u should get simpler when we take the derivative, and dv should get no more complicated. Well, dv is going to get no more complicated no matter which one I pick. Antiderivative of e to the x, e to the x, antiderivative of cosine sine. But u is not going to get simpler no matter which one I pick, because the derivative of e to the x would just stay the same. The derivative of cosine, well, we're just going to bounce back and forth between sine and cosine. So what are we going to do here? Well, what we are going to do is we are going to let u equal e to the x. We are going to let dv equal cosine of x dx. The derivative of u will be e to the x dx. The antiderivative, or the value of v, the expression for v, will be sine of x. And what we get here is that therefore we have e to the x sine of x minus integral of v du, which is e to the x sine of x dx. Well, that doesn't really help us too much because I don't know the antiderivative of e to the x sine of x either. So I am going to let u equal e to the x, and I'm going to let dv equal sine of x dx. And we're just going to do it again, see what happens. V is equal to negative cosine, and what we get here is, we'll separate our u's and our v's, e to the x sine of x minus, don't forget your big brackets, u times v, that's negative e to the x cosine of x, minus the integral of v du, which is another minus e to the x cosine of x, and I'll deal with all the minuses in just a second here. Because what I now have is I have that the integral of e to the x cosine of x dx equals, okay, we had an e to the x sine of x plus an e to the x cosine of x. Minus is a minus the integral of e to the x cosine x dx. And if you're thinking quickly, you might notice that we have two of these integrals, one on each side, which means that I can add the one on the right to the one on the left, giving me two of these. I'm left with these, and I'm going to do a little factor out the e to the x, because why not? And hey, look, if I divide both sides by 2, I get that the integral of e to the x cosine of x, having switched the page, I'm now having to look up at my notes, is equal to 1/2 e to the x sine x minus cosine of x plus e to sine plus cosine of x. Plus a constant. So what am I looking for? I'm looking for things that switch back and forth. And things that stay the same. If I had u equal to some polynomial function that gets lower every time I take the derivative, I don't have to worry about it. But if I've got one thing that switches back and forth and one thing that stays the same, well, then eventually the switch back and forth will get me back where I started. And now I can just combine like terms, divide by however many. Well, it'll be 2 every time. Should be 2 every time. And boom, we eventually get our answer. A little more tedious, a little more step consuming, but it works. So what the heck? All right, my students, go ahead and do exercise 17 out of the book. And we will be back to talk about inverse trig and logarithmic functions. All right. Thanks for watching.